I'm Sarah Sorcher. I'm Deputy Editor of Passcode at the Christian Science Monitor. And we're here to talk about a topic that you actually don't hear so much about in the cybersecurity conference circuit, and that's bug bounties for critical infrastructure and industrial control systems, or ICS. Bug bounty programs are growing like crazy, as I'm sure many of you know. That's where companies allow hackers to search their systems for security weaknesses in exchange for cash or other prizes. And you have tech firms, banks, even the Pentagon, car makers, they're all getting in the bug bounty game. But could these programs also be successful in critical infrastructure? Is it a good idea to let hackers have access to the systems that control the country's electric, water, oil, and gas industries? And so that's what we're going to talk about today. Very interesting topic. With me, I have Casey Ellis. He's the CEO and founder of BugCrowd. That's an organization that facilitates these bug bounty programs. He's also a former penetration tester himself and has spent 14 years in information security. We also have Brian Knopf next to me. He's a security researcher who created an identity management product at OneID, which was specifically designed for IoT and acquired by Neustar. He's now their Director of Security Research, working on IoT industry standards and other products, and is part of Build It Securely and I Am the Cavalry research groups. So thanks very much for joining us.
Thanks for having us.
Thanks for having us.
So I think, Casey, let's start with you. Could you outline for us the landscape of bug bounty programs that currently exist across the Internet of Things spaces, and in particular for products or services that consumers or just generally citizens might consider critical?
Sure. So basically where things are up to, we've seen bug bounties grow from very much like a tech company oriented thing. Netscape actually started the first recognized security vulnerability disclosure program back in 1995. Actually, it turned 21 about 2 weeks ago, which is kind of cool. But what we've seen since then is companies actually adopt the model more for the purpose of being able to more easily access the kind of skills that they need to get adversarial feedback around their systems and to be able to identify vulnerabilities, fix them, and also get better at not putting them there in the first place moving forward. And that includes IoT. So the way that I think about kind of the spectrum there is you've got consumer IoT right down this end, all the way up to ICS systems and internet-connected things that are basically controlling power infrastructure, dams. And really what it is a spectrum of safety criticality and impact on public health if there is an issue, right? And you go from your internet-connected like egg timer thingy down this end right up to the dam, as I said. What we've seen is this progression really along that spectrum. So, cameras, phones, DVRs, like those types of things. We've been running programs on them for the better part of 3 years. More recently, what we've seen is the concept being applied to automotive, which is essentially still an IoT device, but all of a sudden it's a 2-ton IoT device that you sit in and drive. And really what we're seeing now is more and more interest and engagement from medical device security industries and also from internet connected or ICS and SCADA.
And so, we're of course here at an event about critical infrastructure and ICS vulnerabilities. You've heard a lot about that today. Brian, could you tell us a little bit about the bug bounty programs in those areas? Specifically, are they widespread? What's the status there?
It's interesting. I mean, there haven't been a lot of ICS bug bounties. In 2013, there was a company that ran a bug bounty, and they received criticism for it. They were a SCADA environment, and the feedback was partially because of the way they were rewarding prizes, which was licenses to their software, not exactly something that's motivating, but also the fact that there's this implication that you shouldn't be doing it on infrastructure ICS. The problem really is, when you're doing application security and product security and threat assessments, you're looking at the threat model and you have a specific amount of time to do an audit. If you've got 2 weeks, the question is whether you spend your time finding 80% of the vulnerabilities, or do you spend your time on potential high vulnerabilities that if you fail, you come up with nothing during your report. And what I see the bug bounty programs working really well is complementary to that. You run your application security programs internal, you're looking for as much of the threat model as possible, and then you're using these experts that specialize in particular techniques that will come in and either compromise the hardware, other memory techniques, and they'll find those higher vulnerabilities, but you still get a better coverage.
And you're someone who's participated yourself in bug bounty programs in IoT, and you then moved on to more of the ICS space. Could you talk maybe about one or two examples that you personally have seen in your research?
More story time.
And yeah, I mean, maybe that might help give an example of, we heard from Ralph Legner earlier, who said, you don't have to be this kind of super hacker to be able to access these problems in critical infrastructure, and maybe you can illuminate for us some of what he means by that.
I mean, so I've actually been on both sides of this. I've run bug bounty programs, running security at Linksys and Belkin, and then Wink after that, through BugCrowd, and also been a researcher on other IoT bug bounties they've had. So I've seen it from both sides. From the running the program, or having BugCrowd running the program for us, we had a 2-week bounty program. We had 100 people invited, 100 researchers. We got 14 submissions of pretty serious vulnerabilities, one of which would have been worth 10 times the program itself, the cost of the program alone. Ended up costing us $14,000. If you think of that versus a pen test, you're usually paying $10,000 per pen tester per week. So 22 people, the savings on the program alone were significant. For me, it's about making sure that you get the best people on your program, right? It's very hard to hire. There's a very large, a negative unemployment rate in security. So getting the best researchers to focus on your products and getting them interested, whether you give away free hardware, using these kind of platforms allows you to get access to people that you wouldn't otherwise have access to.
And from the research perspective, from when you were, participating in these programs yourself, can you tell us about something that you found in the critical infrastructure sector that you might give an example of the types of things that might be available for outside researchers coming in to find?
I can't necessarily comment on a particular vulnerability from the researcher side because I'm under NDA on that, but from the stuff that I can comment on, there was a vulnerability on a set of IoT hubs that allowed the researcher to essentially delete every one of the users if they wanted to, not just theirs. And things like logic flaws. In this particular case, it looked at whether the user was valid, and it looked at whether the device was valid, but it didn't actually look if the user was valid for the device.
And what sector was this in?
This was consumer IoT, but and again, because the issue with ICS in infrastructure is people are not doing bounties. They're afraid of them. They're afraid of the idea that someone's going to come in and mess with their environment. Now, there have been instances like Hack the Pentagon, which did have fairly good results. They had 1,400 researchers who applied and were approved. They had 138 vulnerabilities submitted, and it proved that government can work with researchers to really help find those vulnerabilities. I think burying our head in the sand and saying it's not going to happen, when especially last Friday, and I know everyone here has talked about it, last Friday was sort of what came to fruition was what many of us have been warning about.
So Casey, maybe you can explain a little bit more about, let's explore some of the reticence, I guess, towards having these programs in critical infrastructure. What to you is something that might be holding these companies back from letting in outside hackers into their systems?
We actually refer to this internally at BugCrowd as crowd fear. So it's basically this idea that hackers are scary people that wear black balaclavas and sit hunched over laptops in their parents' basement. And they should be feared. Like people that have the ability to do this type of thing to a computer are automatically people that you shouldn't trust. That's really the line that I think has been told around these individuals, black hats and white hats alike, for the last 15 years or more. So people, I think, have a natural training and a natural instinct to be fearful of people that are coming in from the outside that can do this. Interesting thing about that is, like, if you think about the evolution of pen testing into the market back in 2001, it was the same thing back then. So it was this question, not so much of who are these people, it's you're going to ask someone to do what to my stuff? Like, this is terrifying. And the progression that the market went through, like pen testing now is a normal thing, and no one really bats an eyelid at it. But it wasn't always the case. So I see this as very much the same sort of thing. There's this hesitancy because of the inbuilt fear of the unknown, but also I think how people have been trained to fear these types of people. And the reality of it is, yeah, okay, there's people out there that can do bad stuff. That's the whole reason we're doing this in the first place. Like the idea of bug bounty programs and crowdsourcing is basically to take the folks that are already at the table. They've been at the table this whole time, as it turns out, and actually extending an invitation to them so that you can get their feedback, get access to more different skill sets, and be more secure.
And do you think in the critical infrastructure space in particular, do you think that there's more of this fear and because of these services being so critical to people?
Definitely. I mean, this is another spectrum that I talk about. Like when you think about where bug bounty started, it was companies that are naturally risk tolerant and quite aggressive in their approach to IT, like Facebook, Google, those sorts of folks. They're on the cutting edge. They're always trying out new stuff. And I think a lot of the rest of the market looks at them and says, that's cool, but you guys are kind of crazy, so we may never do that. What we've seen since, like up the other end, if you've got people that are manufacturing software that controls power grids or dams, you've got a natural risk aversion in that market because of the criticality of what they're building, and that's fine. But what's happening now is that they're starting to realize that. I think the backdrop of this conversation is the fact that and Brian just mentioned it, it's negative unemployment in the US. There's 209,000 unfilled jobs, and this whole idea of being able to get adversarial feedback to understand how we can get better at security, like we actually don't have anyone to do the work. So this concept, what it's doing is it's actually opening up the ability for people to reach out and get input from places that they otherwise wouldn't have been able to reach.
So let's walk through how that would actually happen, because ICS systems are large, they're expensive.
Yep.
They provide services to people that if they go down, there would probably be big problems. So if somebody did find something, that's great because you can maybe fix it, but you can't necessarily just have people live without power for some period of time while that's happening. So what are some logistical ways that we could make this, that you could actually see this start to happen?
I think there's the difference between testing a product and testing a system. I mean, the first thing is you wouldn't unleash the internet to run against a production industrial control system that's running a power grid. That's just insane. So, okay, that's not where you're starting, and I think part of the conversation is to, whoa, that's actually not what we're talking about here. Let's dial it back a little bit. Within those systems, you've got all sorts of different elements. You've got the industrial control units themselves, which are actually pretty dumb. Like they're not, from an attack surface standpoint, it's not that great because they're single purpose and they're built to do a certain thing. Mm-hmm. Where it starts to get interesting from an attacker's mindset or an attacker's point of view is the systems that sit on top of those that people actually interact with or that apply some of the automation to these tasks. And the thing about it is, logistically, you could actually ship that software out to the researchers for them to tinker with on their own time in their own environments. So that's one approach to it. The other that we see a lot of people do, we've been doing a lot of automotive work over the past period of time. There's a couple of public bounties that you can see. Fiat Chrysler and Tesla are two that are out there. But there's a whole bunch of private work that we've done as well, and some of that's been on prototype cars, so things that, they're not just going to ship out to people, obviously. You don't go and distribute 50 cars to researchers and ask for them back at the end. That's not going to work either. So what they did is they put together essentially a bug bash at a conference.
Invited a bug bash?
Yeah, like nice. As in, that's the Australian coming out, apologies. Invited a bunch of people into a room, created a privileged environment under non-disclosure, all the same sort of controls as you'd expect if you were inviting in, say, a third-party consultancy, and got it to work like that. I think for ICS programs, there's really nothing stopping people from applying that same sort of thing. Okay, we're not going to test against production because production is critical in its impact, but what we can do is stand up things in a way that we can actually give people access to, in person, over VPN, whatever else, and basically test against staging.
Yeah. Brian, what do you think? What are some ideas that you might have?
Yeah, I mean, I think Casey, really touched on it. I mean, there's spare hardware that people have as backups. There's the images of the software, the interfaces. Obviously, we wouldn't want to test it in a production environment. Mm-hmm. Typically in a bug bounty, people spin up a test environment. Well, in the ICS, in the infrastructure world, there are backups to every control system.
Yep.
So whether you have a staging version of that where you're testing firmware updates that you can leverage for 2 weeks for that, the on-site works really well rather than sending those kind of attacks over. And having a couple of those, sending them just the firmware image, that can work if for the group that are reverse engineering it, and there's going to be some of those people. And I think allowing the different types of researchers to play with it the way they like, whether they want to reverse engineer the firmware or they want to physically attack the device, allows you to find a larger breadth of vulnerabilities.
And so just one last question, then I do want to open it up to the audience.
Sure.
We touched on the idea of negative unemployment and how there are not, so many people who are, available for all the jobs that are out there. Yes, one, are there enough people who are skilled in ICS systems specifically to take advantage of programs if they were to proliferate? And also, what's at stake if these programs don't happen? I mean, there is something I think a little bit visceral about the idea of your city being vulnerable and letting people attack, whether it's in staging systems or other things. There is this idea of just even admitting that these things might be open to attack.
I mean, I could speak to both. Which one? Let's just put Rocky for it.
Yeah. I mean, I'll say someone touched on it earlier and said, ICS systems, they think about safety first. They do not consider security. In fact, I was shocked when I came from the consumer IoT world to ICS M2M, thinking, there's more money there, I'm going to find more security there, and actually found less security on these devices than you found in the consumer world, which was the opposite of what I would have expected. They always consider safety, but they never considered threat actors that would have motivation to be attacking the systems. So I think the risk is, security by obscurity doesn't work anymore. Just sort of burying your head in the sand and saying, well, why would they want to do it? Well, we've proven at this point people want to do it. Now the question is, do you want to know what it is so you can try and mitigate the risk, or do you want to just ignore it?
In terms of the people that are available, so we've got 40,000 signed up on the platform at the moment. And so what we do is collect a lot of data to understand, the skills, the various skill sets of the researchers that are on the platform, what kind of impact are they capable of, and then also how much we trust them, which comes into some of the stuff that we were talking about before, because sometimes you've got environments where that's more important, right? Within the community, I believe the response rate around SCADA is about 3%. So those are the folks that already have that skill set. They're either already playing with this type of thing on their own time, or they've got a job where they're able to do it for work and then transfer that across to the bounty realm. There's a pretty logical crossover from auto hacking to ICS as well, because you've got this combination of fairly thick intelligence systems, and then stuff like the CAN bus and automotive actuators and controls and things like that. So I see there being plenty of people around to be able to do this stuff. And the other thing of it is, the efficiency of this model is actually what drives its success in being able to subvert some of the resource shortage issues that we've got, right? Because you're paying people based on the results that they get, and they're basically doing the things that they're best at. They're moving on to the next target. So it's actually a far more efficient way to consume human resource to get this type of work done.
The other thing I'd add to it is, you're talking about a group of people who are naturally inquisitive, right? And so even if they don't have experience with ICS, they have experience with IoT or other systems, putting them on it, these are people who will sit and read the entire protocol spec if it's a custom protocol, just because they want to understand how it works. And they think in matrices of how do I get through this system and what are the boundaries of protection. Being able to take people who don't have access to ICS environments and allow them to work on it makes them better pen testers, better researchers, also allows us to get better results.
100%.
With that, I want to open it up to audience questions. If anyone has a question, please raise your hand. And yes, we have one in the back.
Hi. Right now, there's not a lot of incentive, I don't think, for guys to actually report bugs. We have guys who are exploiting systems in a Tesla, and their firmware on their car is downgraded because Tesla doesn't like it. Or Apple are pulling people's accounts because, they're reporting a bug, and then they're getting their dev accounts kiboshed. Do you guys think there should be protections in place? Let's say government protections to protect guys so companies can't come after them if they're showing these vulnerabilities?
That's an excellent question. There needs to be a balance struck between organizations having the legal and I think the civil legal and also the criminal legal ability to have recourse against actual bad actors, right? So just saying, no, everyone's cool to do this, it's fine. I think it's pretty easy to remove those protections if you do that. So there has to be a balance struck there. But to your point, there is a lot of negative reaction to this stuff. There has been in the past. I think, there's a couple of things that are going on at the moment, like the NTIA working group around how do we actually deploy this stuff across the federal policy landscape and then down into corporate. Some of the stuff that the cavalry's doing, the work that Katie Mazuris has done with the ISO standards, and basically just normalizing this concept across the board so that the expectations are aligned. Like the biggest cause of failure in these programs, and I think this has historically always been the case, is when the expectations are misaligned. So the researchers are coming in expecting some set of behavior, or the vendor is expecting a particular set of behavior, and for some reason that just gets kind of out of whack. That's when that type of thing happens. That's very much a feature of the old world when it comes to this stuff, and I do think we're evolving, which is good.
It also is how you deal as a company with the researchers, right? I mean, if you treat them with respect as opposed to why would you touch the system?
Yeah, 100%.
That reaction changes very fast, that initial contact with them. And when you see support people respond with sort of harsh tone, a lot of the researchers kind of get taken back and then respond harshly in kind. And that's where you see mistakes made where people go, oh, well, I'm going to grab this data to show that I have this vulnerability, which is that line that you can't cross.
Yeah.
And so making sure that the interaction between companies and researchers is a mutual respect one, that changes the game a lot.
Any other questions?
This is Josh Corman. One of the things that's confusing for the ICS world, who's relatively less experienced dealing with white hats or researchers, is they're hearing conflicting messages from the cybersecurity industry of you should do this instead of a pen test, you should do this instead of static and dynamic analysis, you should do this instead of a software development lifecycle, it's cheaper, we'll get more bugs. And one of the things we find in the NTI working groups on the safety critical working group is that for these safety critical ones, starting with a cash reward may actually give you a very high volume that you're not necessarily prepared for. So if you look at a maturity model of I've never done anything with a researcher before, how would you place bug bounties and coordinated disclosure programs in that maturity cycle so they don't get ahead of themselves?
Sure. Definitely for a public program, I agree. Like the concept of going out to the open internet and saying, hey everyone, come and do this, we'll reward you if you do. That's something that only organizations with most, if not all, of the rest of best practice SDLC in place, is appropriate for them, right? That's not the only way to run one of these things. I think the concept of basically crowdsourcing a pen test and replacing parts or all of that with a model where you're going out to more people. You can do that without running a public bug bounty, and I think one of the things that we see pretty consistently is because of the efficiency of the model, it creates an impact on the customer's end that actually drives investment back into some of those other things that might have been missing, right? So I agree in terms of in a perfect world state, you're doing security by design from the very get-go, you're doing SCA, you're doing unit testing, you're doing pen testing, you're doing bug bounties, you're doing vuln disclosure, boom, as your kind of set of things that are best case scenario. But to say that you shouldn't do one because you're not doing one or two of the other, I don't necessarily agree with that, because there's more than one road to Rome.
I think you can do, I look at a bug bounty as complementary, but as Casey said, you don't have to have full SAST and static and dynamic analysis tools running. You do need an understanding, at least one or two people, of how to take those vulnerabilities and fix them.
Yes, definitely.
But so I wouldn't recommend to someone that has no security knowledge in their organization to go run a bounty, and they'll be overloaded by trying to fix it.
Yeah.
But that doesn't mean you need a 20-person team. You can do it on a shoestring budget and say, okay, I'm going to run this bounty. I've got one or two people that know how to review the code and review the vulnerabilities. There are services to help you with that, to triage so you're not overwhelmed. And then you build, as Casey said, you build the, hey, this is what I expect to find. This is what we found. Now we can fund the program a little more.
Yeah. Brian touched on a really important point there, just in terms of what do you do after you find this stuff out. And That's actually the one exception that I would put in all of this, and I think it's one of the key challenges for ICS as well, because you've got organizations that have been around for a long time. A lot of this stuff has actually been in production for ages, so you've got an old code base, which is naturally more difficult to remediate when you find vulnerabilities. Your regression testing goes deeper. You've got to dig up people that wrote code 10 years ago and figure out what they were thinking, stuff like that. So there's a natural, I think, it's naturally harder for ICS to get good at that. But that's all part of what needs to happen to reduce the risk. So, it's going to happen at some point.
Great. All really good food for thought. Thank you so much for joining us.
Thank you.
Thank you.